Hello friends, myself R.D. Mahajan, Assistant Professor, MIT Aurangabad, presenting my video on triple integration. In the previous video I have discussed the first example. Today I will discuss second one. Evaluate triple integration of integral from 0 to 1, integral from 0 to 1 minus x, integral from 0 to 1 minus x minus y with respect to x, y, z. Therefore, we have to observe the limits very carefully to decide the order in which we have to perform that triple integration. Here the inner integral in terms of x and y means it must be for z, and therefore I have written here the limit from z equal to 0 to z is equal to 1 minus x minus y. Means we have to first integrate it with respect to z. Then remaining are two variables x and y. The second integral is in terms of x, means it must be for y. Therefore I have written here y equal to 0 to y equal to 1 minus x, means we have to integrate it with respect to y. And therefore the last one, outer integral, limit must be for x is equal to 0 to x is equal to 1, means we have to integrate it with respect to x. Therefore this step is very, very important, where we have to decide the order in which we have to perform that triple integration. And after deciding that, we perform that integral, and therefore I is equals to integral from 0 to 1 dx as it is, no change, integral from 0 to 1 minus x, integrating this z dz with respect to z, its integration is z, and limits from 0 to 1 minus x minus y, and whatever that result, then we have to integrate it with respect to y. A first step. Steps are very simple. Integral from 0 to 1 with respect to x, integral from 0 to 1 minus x, substituting the upper and lower limit for z. Upper limit is 1 minus x minus y, lower limit as 0, and then that we have to integrate it with respect to y. As 1 minus x is constant outside, and integration of dy is y, and minus integration of y with respect to y is y square by 2, and the limits from 0 to 1 minus x, and its integration with respect to x, and therefore it is equals to integral from 0 to 1 1 minus x as it is, substituting the upper and lower limit for y as upper limit as 1 minus x, lower limit as 0, minus 1 by 2 constant term outside, upper limit square, it is 1 minus x bracket square, and minus 0, and then we have to integrate it with respect to x. Okay, and therefore it is integral from 0 to 1, this 1 minus x and this 1 minus x, it becomes 1 minus x bracket square minus 1 by 2 1 minus x bracket square, its integration with respect to x, and therefore it is integral from 0 to 1, taking 1 minus x bracket square as a common term, remaining terms are, here it is 1 minus 1 by 2 and 1 minus x bracket square, which we have to integrate it with respect to x. Okay, and therefore 1 minus 1 by 2 is 1 by 2. As it is constant, I can take it outside the integral sign. Integral from 0 to 1, and remaining term is here 1 minus x bracket square and its integration with respect to x, and therefore it is equals to integration of 1 minus x square bracket square is 1 minus x raised to 3 2 plus 1 divided by 3 and divided by its coefficient of x. Coefficient of x is a minus, and therefore divided by minus 3, and limits from 0 to 1. 1 by 6 minus sign I will cancel by changing the limit. Therefore x is 0, we get 1 cube as 1 minus lower limit as 1 minus 1, we get 0, and therefore the final value or the answer of this triple integration is 1 by 6. Okay. Therefore this is the value of that triple integral. The order in which we perform that triple integration is very important, and for that we have to see the limits very carefully. Here it is in terms of x and y, means inner limit must be for z, remaining are 2 y and x. Here it is in terms of x, means it must be for y, and therefore final or the outer integral must be for x. Therefore this is the order in which we have to perform that triple integration, and therefore performing it step by step we get the value as 1 by 6. If you are watching my videos, please like and share it, as well as subscribe to my channel for new videos. Thank you very much.